In this video, we're going to solve the median of two sorted arrays problem. The median is the middle value that divides the array into a lower half and a higher half. If the array has an odd number of elements, the median is the middle value. So 1, 2, 3, the median is 2. If the array has an even number of elements, the median is the average of the middle two values. So 1, 2, 3, 4. The median is 2 plus 3 divided by 2, 2.5. If the median divides the first array into two halves, A1 and B1, and similarly divides the second array into two halves, A2 and B2, we should have A1 less than or equal to B2 and A2 less than or equal to B1. Because each array is sorted by itself, we also have A1 less than or equal to B1 and A2 less than or equal to B2. So A1 and A2 are in the lower half and the B1, B2 are in the higher half. Also, each half should have half of the elements. If we denote this by I and denote this by J, note that J is determined by I. If we can find the right I such that these two conditions are true, then we can find the median value of the arrays. So nums 1i is the element in the first array, and the nums 2j is the element in the second array, where j is determined by I with this equation. These four conditions are true is equivalent to these two intervals have overlap. Why? Because when these two intervals have overlap, the two upper bounds will be greater than the two lower bounds. Since every element in B1 and B2 is greater than the minimum of the two upper bounds, B1, B2 are in the higher half. Similarly, A1, A2 are in the lower half. The two lower bounds and the two upper bounds are the four middle values in the array, and we can get the median out of the four middle values. If the two intervals do not overlap, it could be like this or this. In this case, we'll move I to the right to make the two intervals overlap, and in this case, we'll move I to the left to make them overlap. In either case, we'll only search in one direction. This is where we can apply binary search to make the search faster. With this idea, let's jump into the code. We always make the first argument the array with fewer elements. This makes the search faster as we're searching in a shorter array. Mn are the array length. We search in the first array. Low, high are the bounds for I. Where low is less than or equal to high, there is still something we have not checked. We make I to point to the middle of the interval. J is determined by I. We then get the four bounds of the two intervals. Note that ij could be out of bound. In that case, we make the negative infinity and positive infinity respectively. This does not affect the correctness and makes our code much simpler as we're dealing with fewer edge cases. This condition checks if the two intervals overlap. If they do overlap, we get and return the median value. If the array has an even number of elements, the lower half has the same number of elements as the higher half, and the median is the average of the middle two values. If the array has an odd number of elements, the lower half will have one less element than the higher half, and the median is going to be the minimum of the two upper bounds. If R1 is greater than R2, we only search in I's left. else it means L2 is greater than R1. We only search in eyes right. The time complexity of this algorithm is O of log min m n. Let's submit the code. And it is accepted.